Hi, my name is Brian Lau, and today I'll be showing you how to do a heat transfer simulation of a heat sink in Autodesk Fusion 360. So I have a heat sink right here. So a heat sink transfers heat from the components, computer components, which are on the bottom, into the ambient air through these fins right here. So I want to see the temperature distribution when the computer components are running. So first of all, a brief word about heat transfer. So heat transfer works by two different modes. So you have conduction, which is heat transfer from particle to particle from the computer components on the bottom throughout the heat sink, and you have convection, which is heat transfer from these faces, from these fins into the air. So to run the simulation, you go to Design, select the drop-down menu, you go to Simulation. So I'm going to close this one. So I click on Study and New Simulation Study. I'm going to select a thermal simulation because I am trying to find the temperature distribution of this heat sink. And then I select Create Study. So the first thing we need is to assign materials. So to do that, you right-click, Study Materials, and I want the material to be copper. So my heat sink is now made out of copper, and now I select my loads. So my loads are my boundary conditions. So what's going on the surface? Is there a constant amount of power coming in? Is there convection going on the surface? Does one of my surfaces have a constant temperature? So those are the things you specify under loads. So I right-click thermal loads. All right. So the first load I'm going to have is an applied heat source from the computer components. Since the computer components are attached to the bottom, that's where my heat source is coming from. So I select the bottom surface, and the computer components generate, let's say, around 10 watts of power. I click OK. The next boundary condition I want to specify is the convection boundary condition across the fins. So that's where heat is being transferred into the air. So I right-click on loads, I click on thermal loads, and then I click on convection boundary condition. So I select my faces. So I'm going to scroll around, select these faces. So, I need to select my bottom faces too, since heat is also being transferred out of the bottom part of the fins too. Okay. So I have to select my convection coefficient. So I calculated it already around 30. And the ambient temperature is room temperature, which is around 25 degrees Celsius. I click OK. So I have my materials, I have the boundary conditions. The next thing I need is the mesh. So how Fusion 360 solves this problem is that it breaks the problem down to tiny pieces and then into elements, and then solves each element and puts it back together to get your temperature distribution. So it does this using a mesh. So I right click and I click generate mesh. So right now it's meshing right now. So now I have my mesh. So now since now I know my material, I know what my boundary conditions are, I have the mesh, I can run this study. So I go to solve, and I click solve. So, and then I click solve one study. So this model is being exported into the cloud where the software solves for the temperature. So it's not being solved on my computer, it's being solved externally. And the advantage of this is that the computing power of the cloud is much more than that of my computer. So now I have my results. Click close. And this is the temperature distribution of the heatsink. So we can see that this test is reasonable. We have the highest temperature occurs on the bottom, and the coldest temperatures, the minimum temperatures, appear towards the top. So I see that my maximum temperature is 26.62 degrees Celsius, and my minimum temperature is 26.33 degrees Celsius. So that's my temperature distribution. Let's look at heat flux. So heat flux is the amount of heat going through a particular area. So we can see that the heat flux is pretty low, which is good. And here is the thermal gradient. So that's how the temperature is changing throughout the heat sink. So my simulation has been completed, and I'll select Finish Results to accept them. So there you have it. That's how you conduct a heat transfer simulation in a computer heatsink.